Here. So, paperclip test here. Okay, now the power unit. If there is a risk factor, this computer will be. Let's putting a power unit here. So power unit is the camera. If this computer now power ups automatically itself, because here electrical current 230 volt is selected here. Is this working this unit? It is a power unit now. It's broken, and the sound that is able to power up itself up here. Okay, now the power is on, and the power clip test here. You see, but you should be touching anything here. But let's take a look around how much the power there is. Okay, I don't know what shows, what doesn't show. But here it is, the multimeter, and it could tell about the stuff what does work here. Let's take a look at bullet test unit here. Okay, here we go. Let's just say that the AC here, this power, it shows 2.6 volt. This shows 3.4 volt. So it is the case with a leak. Interesting way this is a difference about here. This is a 2 randomly. It's really varies basically. This lost a little bit, okay, so no power. How does the power paper clip here, okay, so if you're looking for a hertz, okay, so we should be getting 50 hertz, okay, so okay, getting nothing, 50 hertz here, and here I got the 50 hertz here. Where I got 50 hertz here? In here it's running like at 50 hertz here, so like it is. Even if I'm not hitting off this machine here, maybe this whole code didn't dish machine, so now it's 0 hertz. So when I touch this thing here, it's not easy to be here. Something's conducting here in this rubber city here. Look at this. Something is. Okay, now look at this system here. 50 hertz I can measure here. In this, when it's hitting here, around, and anytime there's a metal part, okay, so yeah. These are grounded. This is an important fact. Important factor for the computer science is a grounded here. I don't expect the bar to put anything inside there. This power machine isn't because it would be group, you know. What? 4960 is the 1000 here. Is there? Something's wrong here. But I don't know where. Listen, anyway. There's some interesting noise coming from this machine. So take off this thing here. Now the machine noise is off. There's a spin around here, this machine here. Yes. So it seems to be the case that it's really able to run itself, this machine. So the paperclip test seems to be passed. It's not smart to put this on machines, but this kind of a. So we could test about hertz here, example here. Then we're looking for a direct conduct here. Is it a smart really putting inside this machine? So first of all, you need to know about the electronics here, okay, so it's conduct here, okay, so here's a volt is port, okay, so and the second part is ampere part here. You can measure all kind of variances here. Let's see about what this shows about here. Okay, now we're putting here. Doesn't anything work anymore here. Okay, now hertz still very little. 127. Immediately hitting off this machine. There seems to be something continue. Then there's another thing. 0. There's nothing. Once again 0. Conduct the resistance. Maybe resistance could be measured about here. Other thing. Okay, conductance, impedance, capacitance, nothing work here. Well, here is interesting looking for ampere. Amperes. Let's take a look for amperes for this theoretical part. Oh, look at this. There was a shit. Maybe it's a smart thing. I didn't destroy the machine, but it shut down because of there was a. It wasn't actually. Maybe I don't know capture about it here. Maybe I shouldn't be putting off this ampere meter. Meanwhile, There was a little case on a power outcut. Well, that was true. Take a look at here. 5. So there's still power current. It's just shut down. It's automatically power shut down. Let's take a look again here. How dangerous is it? Now it doesn't automatic anymore. Restart. Did you destroy this machine by simply? That's stupid. How much volts we get here? 3. Is it to work? Maybe you should not measure of the amperes, because why not? Here we go. There was some power shortcut. So what this kind of a clues can help around here? We have a 230 volt gauge on here. Listen. Amperes. I have this music player, I guess, and I'm playing myself here. So, did you destroy this machine by amperes? Okay, you don't know what you're doing here, I guess, after all. Maybe no smart thing to do, so putting on some kind of amperes here. Look at this. I don't know how smart this is here, but like, look around here. I get nothing. And here it's here. Nothing. Nothing. So let's go to voltage gate here. I don't know how dangerous it. I just putting a risk. Most likely this machine, not myself. So a small battery here. This machine. There is a 3 volt coming out for this machine. But did you destroy that? The case on was a smart thing here. The paperclip test seems to work. And paperclip, of course. Okay, so kind of there should be the same 50 volt here. Okay, so okay. Sorry, so this machine doesn't even go and work right now. What I had to do was a smart thing to opening up here. The conductance of the capacitance. Okay, 230 is quite dangerous, but now it doesn't run anymore. So it looks like I have maybe destroyed this power unit. Just open the application. But this is a stupid thing here. Very stupid thing it did here. Okay, now we'll remove it off. And remove this power unit off. One of the crazy stupid thing is ask about this is smart putting, and this has 600 volts in this thing. Here's a power. It's a paperclip test, and directly in this machine here. Is it smart thing to do about it here? I don't know. So I have here a hand case and some clues here. Well, one of the important factors is that there's clues. I don't know how they're conducting electricity, but well, they are not metal, I guess, and they are not our best metal. So how can you sense the insulate against the electricity here, guys?